All right, so we're starting day 3, and now we are officially actually in lesson 7.3. So day 1 and 2 were just revision of previous concepts that you kind of need to know to understand this topic. All right, so you guys remember these triangles. They're going to be very useful, and we are going to continue to use them throughout this entire lesson. All right, so for today, what we're going to be doing is learning how to calculate molecular mass or molar mass of a compound or of a molecule, okay? So you know that the formula of a molecule tells you a lot, or of a compound, tells you a lot about that specific compound. It'll tell you the number of each element, and it'll also tell you what elements are found in your compound. So for example, this compound contains 2 atoms of aluminum, 3 atoms of sulfur, and 12 atoms of oxygen. This is basically because this 2 belongs to this aluminum, and sulfur, you take this 3 and you multiply it by each. So sulfur ends up having 3, and oxygen has 4 times 3, which is 4, 8, 12, right? So this tells you a lot about your compound and how many of each element you have, and this is going to be very important throughout this lesson. All right. Another thing, when you know your compound, it'll help you to determine your formula mass, your molar mass, and your percentage composition. We'll get to percentage composition next week, though. All right. So you guys remember Avogadro's number and all of these cool things. And you remember that molar mass of an element can be found here in your periodic table. So if you look here, the molar mass of chlorine is 35.45. Please do not ever use the atomic number. Atomic number has nothing to do with this lesson, okay? The molar mass of krypton is 84.80, of magnesium is 24.31. So whatever atom you have, you can find its molar mass here, okay? And the same thing is going to apply when we get into the molar masses of compounds. Now, unlike atoms, you can't find the molar mass of a compound straight up in the periodic table, but you can use the molar masses in the periodic table to find the molar mass of your overall compound. So let's say here, zinc chloride, right? I know that the molar mass of zinc right here is 65.38. And if chlorine is 35.45, and I know that I have 2 chlorine atoms. So basically, to find the molar mass of zinc chloride, all I have to do is find the molar mass of zinc and add it to the molar mass of 2 chlorine atoms to find the mass of this overall substance or this overall compound. The same thing applies to all of these. So you can do it this way, where you find the molar mass of each element and the number of them, then add them all together. I do it in a slightly different way, but whatever is more comfortable for you is what you can follow. All right, so let's say here I want to find the molar mass or the formula mass of water, H2O, right? So the first thing I'm going to do is I'm going to find the molar mass of hydrogen. I'm going to go here to my periodic table. I'm going to find hydrogen right here. It's 1.01. Okay? So 1.01. And then I'm going to find the molar mass of oxygen, which is right here, 16.00. All right, so of oxygen is equal to 16.00. And remember, they're both in units of grams per mole because we're talking about molar mass here. So now let's go ahead and create an equation. You can either do it my way, this is the way that I do it, or you can do it this way. It's up to you. This is kind of how I do it. So I would say 2 times hydrogen plus oxygen is equal to question mark, which is, you know, big M, molar mass. So this 2 right here this 2 came from there. And the reason there's no 1 here is because there's no reason to put a 1 there. Anything times 1 is the exact same number, so we don't usually write it. All right, so now let's go ahead and substitute everything in. So 2 times 1.01, this is the molar mass of hydrogen, plus the molar mass of oxygen, 16.00, is equal to approximately 18.02 grams per mole of of water. So by using or by knowing the molar mass of hydrogen and the molar mass of oxygen, we were able to find the molar mass of water, okay? And remember, if you have more than one of an element, just like here, how we have 2 hydrogens, you have to account for that by multiplying it by 2. All right, so let's try another example right here. So here I can see that I have 1 calcium and I can see that I have 2 chlorines. That's because I'm going to take 2 times 1 equals to 2. So I have 2 chlorines, and then I'm going to do this. So the number of oxygens is actually equals to 4 times 2, which is 8 oxygens. Okay? So now I've got to find the molar masses of each of my compounds in my each of my elements in my periodic table. So let's find calcium, chlorine, and oxygen. Let's see how much each one is. So first of all, I can see calcium is right here. It's 40.08. So 40.08 grams per mole. All right, and now let's find chlorine. Chlorine is right here, 35.45. 35.45 grams per mole. And then I can find oxygen. I just have this one memorized, but you can obviously go into your periodic table because you probably don't have all these memorized. Now let's create our equation. Calcium plus 2 times chlorine. Remember, we're doing this because there are 2 chlorines because of this little number right there, okay? And then we're going to add the 8 oxygens, okay? And this is going to give us our molar mass. Remember, this number 8 came from here because it's 4 times 2. All right, so now let's go ahead and substitute all of our numbers in. So calcium is 40.08 grams per mole plus 2 times 35.45 grams per mole plus 8 times 16 grams per mole. All of this is equal to 238.98. Yes, I know that was a lazy move, but I can't keep this video going for 5 years while I put this numbers into the calculator. All right, so there you go. We have our grams per mole of calcium perchlorate. All right, and now let's try one more. So first of all, we know that we have 2 nitrogens and 6 oxygens. It's because the 2 goes here, 3 times 2 is equal to 6, okay? So we have barium, we have nitrogen, and we have oxygen. Let's find their masses. So I know just from myself, this is 16 grams per mole, and nitrogen is 14 grams per mole. Now let's go and find barium. Let's just double check. Yes, barium is right down here. It's 137.33 grams per mole. So 137.33 grams per mole. Okay? So let's go ahead and create our equation. Barium plus 2 times nitrogen plus 6 times oxygen is equal to our molar mass. So now let's go ahead, 137.33 grams per mole plus 2 times 14 grams per mole plus 6 times 16 grams per mole equals to, again, I'm just going to go ahead, 261.35. All right, so now you guys remember, you will most likely need a calculator to get all of this done. I did all of these ahead of time, but I don't want to make you guys wait for me to do all of these. All right, so that's basically how it's done. So step 1, you find the molar masses based on what you see in the periodic table, okay? And then you create an equation which allows you to combine the molar masses of every element in your compound and the number of those elements in your compound. And then you just substitute them in and calculate, and you find the molar mass of your compound. Now this is going to be important because tomorrow we're going to start using the molar mass of your compound to do calculations involving molar mass and moles and number of molecules and Avogadro's number and all of that. So this is something you guys really need to get down, so make sure that you are actually practicing it, okay? Of course, if you're confused, you come back and rewatch the video, and if you have questions, you can just send me a message and we can discuss where you're having problems.